The soldering station I designed and built myself is completed. It contains power supplies for connected tools, pump and electronics. There is vacuum pump for the soldering gun and 2 controllers, one for tweezers and one for gun. All is together in one enclosure. I showed you already design and building the bottom part driving the ZD915 gun in previous video. This is part 2, focused on controller for SMD Tweezers. I started with cutting the aluminium front panel and fitting TFT screen with Arduino Nano at the back of it. Potentiometer to set the temperature and socket to connect tweezers to the controller. This is front panel. It's all assembled. Obviously socket for the tweezers. There are 2 LEDs that are going to indicate the heaters on, connected to the drain of the MOSFET. Then obviously the knob to set the temperature, display with the temperatures and temperature set, and then standby switch. At the back it looks busy here, but it's really only a few components. Display and Arduino Nano. They're connected through the board that is converting 5 volts output from the Arduino to 3.3 volts logic on the TFT display. Then we have obviously the switch. It's not wired yet. LEDs. Then we have potentiometer, 10 kilo ohm potentiometer to set the temperature. And then 2 MOSFETs through 100 ohm resistors that are controlled by Arduino outputs. Here is the socket that is being wired to positive, 18.5 volts positive, and then it goes to the heaters, and then return from the heaters goes through the MOSFET's drain into the negative power supply, 18.5 volts power supply. Then we have positive for the 5 volts for the Arduino Nano and display, and max 6675 temperature decoders. And the temperature decoders, there are 2 of them because there are 2 thermocouples in the tweezers. The temperature decoders are connected to the 4, 5 and 6 pins on the socket. The 4 is common and it's negative for both boards, and then we have positive from thermocouple 1 going to the this board, and thermocouple 2 going to the other board, and then everything is connected through SPI into the Arduino Nano. So there are basically 2 chip select wires, but the clock and data is common for both decoders. And this is essentially it. So everything is connected to the front panel. All I need to do right now is to get my station that already has all the working circuitry for the soldering gun and build another floor, as I call it. It's going to be third floor, third level of the station. Hopefully the last, but who knows. And then with some holders for the tweezers and for the gun on top of that. That's the plan at the moment. We'll see how this is going to work. There is 5-volt output already from the station, and there is 18.5 volts output again already sorted. So all I need to do right now is to build support for this front panel, connect the wiring to the front panel, test it, and hopefully it's all going to be working nicely. I've already described in the previous video what is going on here. All of this is for the soldering gun, and I built a third level to the station for the tweezers. So from the two power supplies that I have, the 5-volt power supply and 18.5 volt power supply inside that you could see before, I got the voltage of the power also through these cables. So that's 5 volts, that's 18.5 volts, and there is also a signal coming from the Arduino here, because obviously it's only one controller at a time, so I can use either the gun or the tweezers, not both at the same time. So when I activate the gun, tweezers will be off, and vice versa. And this switch here is basically controlling the standby for the gun. So when the gun is in the standby mode, then the tweezers can be on. When I switch on the gun is on, the tweezers are off. This is the all electronics with the plug that will connect to this plug. So this is the signal that goes from the Arduino in the bottom to this Arduino, and then there's 5 volts and 18 volts for the MOSFETs here, and for the socket. So that's the thing. Now there's already sort of like a plug fitted in the back. There is back cover to keep everything safe, with some ventilation for the power supplies. The ventilation there is also some ventilation here at the bottom, and there is going to be ventilation here on the side and on the top. I'm going to show you this in a moment, and we can assemble everything now together. That's the top cover for the rear, and then we have the housing for this part. So this is the top, and here you can see there is opening on the side where the ventilation is going to be. There is also opening here. That's done on purpose, that it is not flush with the top plate. It is to allow some out from the inside. I've also have a holder on top for the gun. So basically that keeps the gun here, and the tweezers are going to be sitting on top of that here. So this is the arrangements for the holder. That's how the tools are going to be. And then all is left is to connect this plug, get everything inside. Inside I'm going to sort of like secure this plug. It's not going to be sort of like freely hanging in, but for the time being I'm just going to get it in. Program this Arduino because it does not contain all the software, but this is basically how it's going to look like. Temperature setting for the gun, temperature setting for the tweezers, standby switch and switch between the tweezers and the gun, and then this is standby for the tweezers, 2 sockets, tweezers, gun. This is for the vacuum pump, and this is main switch for the station. Holder on top. There will be a holder for the tweezers sitting next to it, and yeah. So that's the mechanical part. Now all I need to do is to get the software for the tweezers sorted. And I hope that's going to be a great tool. How big it is? It has a height of 20 centimeters by 14 centimeters, and the depth is 24 centimeters case if you include the knobs. It's going to be 26 centimeters. So, and the height with the holder here, with the top of the holder to the top of the holder here, it's going to be again about 26-27 centimeters. It's quite heavy also. I haven't weighed it, but I haven't sort of tried to get the proper measurement how much does it weigh, but it feels quite sturdy. I think it's mainly the power supplies, and the vacuum pump is quite heavy. I finally managed to get the soldering station project to an end. So in part 1 I've already showed you the soldering gun station. So this is all working absolutely fine, no problems. And the second part of it was to add the soldering SMD tweezers to the station. I showed you the pinout in one of my videos, and now here is the controller that is ready and working. How all of this is supposed to work? Well, the station, that's how it looks like. The station is supplied by the mains. Here is the main switch for both levels. Inside there is power supply for logic, 5 volts, and there is power supply 18.5 volts for the gun and for the tweezers. Now there are 2 standby switches. One is for the soldering gun, and then the other one is for the tweezers. Only one tool can operate at a time, so either gun or tweezers. So basically the gun needs to be in standby for the tweezers to operate. If I get the gun out of standby, then you can see that here is a message: the soldering gun in use, and the tweezers are going to be off. If I switch off and the gun is in standby, then the tweezers can be switched on. So if I switch it on, the heaters go on. You can see the red color indicates that the heaters are on, and the heaters are start to work. Obviously temperature setting, so here is a temperature and here is a temperature in both handles, handle 1 and handle 2. So that's basically what it does. These two LEDs show the actual MOSFETs on and providing power to the excuse me, providing power to the tweezers. These two LEDs show there is power in, there is basically supply to the two PSUs that are inside. These are MOSFETs for the soldering gun, and this is a LED showing the pump, vacuum pump is working. Actually, it's pretty decent accuracy. It's all on Arduino Nano, and here if I measure the set at 330 at the moment, so let me just touch the, so as you can see the real temperature, measured temperature is around 330. It depends really where I touch these tweezers. Here, where do I put my probe? But it's reasonably accurate. Here we go. So overall, I'm quite happy with the whole project. Obviously this is going to go, let's put it on standby. Obviously this panel together with all the electronics is going to end up in there, and then the tweezers will have its place here on top. So on top of it, of the station, it's going to be holder for the tweezers. There is already holder for the gun, and that is going to end up inside of it there. Yeah. So let me explain how this is built, what this controller consists of. So there are two power supplies coming in and one signal from the controller for the soldering gun. So we have a plus 18.5 volts, and that's coming in from PSU. And then we also have 5 volts coming in, plus 5 volts for all the logic. Here is Arduino. Arduino Nano. Grounds are obviously connected together, and there is also signal from the controller for the desoldering gun coming in. That's his standby on signal. So when the desoldering gun is on, only then Arduino is going to operate tweezers. Arduino needs a analog input to decide on temperature setting. So that's basically pot 10K pot to A0. That is for adjusting temperature. There is also another switch to ground, and this is standby switch for the tweezers. And then Arduino controls tweezers connected to the socket. Put the socket here through digital output. So there are basically two MOSFETs. So we have MOSFET number 1 and MOSFET number 2. This is drains, and there is another drain. So that is drain of the MOSFET, and here we essentially have N-channel MOSFET. That is going to control our tweezers. These are digital outputs on Arduino. I don't remember whether it's D4 or D5, I think. This positive line goes to the socket. So here we need to put the socket. I'll try to make it as nice as possible. And we have three pins here. I'm not going to sort of like put them exactly in the spot where they are, just to give you an idea. So this goes actually to pin number 7, and these two go to pin number 1 and pin number 2. They are not located like that, but basically positive rail goes to the common for both heaters, and then heaters are switched on by the MOSFETs through the drain and source to ground, and the gates are controlled by the by Arduino. I added 100 ohm resistor here and 100 ohm resistor here to the gate, and that's basically it. There's also 100 kilo ohm actually resistor here to the ground. That is not really that crucial, but it is there. So that's the control of the heaters. Now, what's happening with the monitoring, temperature monitoring? As we know, the 3 pins are responsible for controlling controlling temperature, and I'm going to put max the thermocouple. So here we have max 6675 number 1 and max 6675 number 2. Both marks are going through the SPI. Okay, there are obviously three rails. I'm just going to schematically put this like that. So this is SPI. So there is clock, there is master in slave output. They are common for both marks, and there is chip select 1 and chip select 2. So we need 4 pins essentially controlling marks. Now there is, as we know, thermocouples have negative connectors together. So if we say this is negative for both, so that's TC1 plus TC2 thermocouple, and then if we say this is TC2 and this is TC1, so this is going to go here, this is going to go here, and the negative is going to be shared by both. Okay, I hope you have the idea. So basically both thermocouples are, if we schematically put thermocouples like that, so that's the common, that is negative, and this is positive of TC1, and this is positive of TC2. So we have 2 thermocouples on 3 pins. And then obviously we also need TFT display, or any kind of display. In my case it is TFT, that is running ST, don't remember, it's 7035, I don't remember exactly the symbol, and it's again connected to the SPI. So we need another chip select plus reset plus master out slave in MOSI, and obviously clock that is shared between those. And then 5 volt rail goes from Arduino, so all these are connected to the common ground, and then 5 volts goes to each of those devices. That's plus 5 volts. That is shared together with Arduino, and that's essentially in. There is a 7th pin here on the pin number 3 on the socket that is not connected. This is normally earth, but this is not earthed and not grounded, and that's essentially all the schematics. Now I had some problems finding a library that would work together with TFT. I think TFT is quite busy with all the SPI communication between the Arduino and TFT, so I struggle a little bit with Max. So in the end I've compromised, and actually the way I did it in the end, and that's what took me quite a bit of time, was to put another Arduino that is reading temperature and then is communicating over I2C with this Arduino. So they're actually in my design. There are two Arduinos communicating together, but I'm pretty sure someone who is slightly better at Arduino code would be able to sort out SPI and share this between two Max 6675 thermocouple decoders and TFTs. And that's it. So 18.5 volts, 5 volts. There is standby from the desoldering gun. Arduino Nano is controlling everything. There is a temperature pot to this temperature setting potentiometer going into analog input. There is a standby switch going into digital input. There are two digital outputs for controlling MOSFETs, for turning MOSFETs on, and turning plus 18.5 volts to the heaters on and off. And there is this temperature reading on SPI rail with Max 6675 and everything, all the user interface, all the information for the users going out into TFTs. If you wonder about heaters, I explained this about in the movie about tweezers, but basically it's very similar actually set up to thermocouples. So there are three inputs, and the heaters are between them. This is pin number 7, this is pin number 1, this is pin number 2 in the sockets, and that's heater 1 and that's heater 2. So by enabling 1 and 2, you can control both heaters independently. For me, this is plus, and that is on the drain, and this is on the drain of the MOSFET. So this is essentially a very brief schematic and idea how it works. And Arduino Sketch, it is not something I'm terribly proud of. Standard library for TFT, standard library for the Max 6675, and then some ifs for controlling incoming signals. And I'm very happy that these tweezers are actually together with the soldering gun in one package. That saves me a lot of space, and also it works the way I want it to work.